Ellie, and today I will be teaching about the structure of sugar, specifically how the structure of sugar allows it to caramelize while baking. Today, by the end of the video, you should know how and why sugar caramelizes while baking. So, I'm a food science major. I'm always curious about what I put into my body and what is in food. And one of the specific foods that I've always been curious about is sugars, because I have a major sweet tooth, so I put a lot of it in my body. So, what is sugar? What are its chemical properties? What is it made up of? A sugar property I've always been curious about is its caramelization in baked goods. Caramelization, sugar being reduced when it is exposed to high heat, makes baked goods turn brown in the oven and taste sweet after baking. But why? I'll explain. But first, let's get to know the carbohydrate known as sugar, specifically sucrose. The sugar typically used in baking is sucrose, also known as table sugar. It's a disaccharide made of the monosaccharide units glucose and fructose. Glucose and fructose are 6 carbon chains with the formula C6H12O6, and they're usually a ring in the presence of water. Glucose and fructose are structural isomers full of energy due to 7 energy-storing CH bonds, and they only differ in the position and orientation of their carbonyl bond right here. Sucrose is extracted from plants and vegetables that manufacture it through photosynthesis, like this lovely spring mix full of spinach leaves. Sugar's ring structure allows it to have many sweet properties when baked. Baking is dry heat roasting in an oven, a process where the temperature is lower but the time is higher. It could be more than several minutes. Sugar gets crispy in baked goods when it's recrystallized after water is removed due to heat evaporating it in the oven while baking. Baked goods turn darker when sugar in them browns due to non-enzymatic chemical reactions which produce colored compounds at high heat. Browning also releases enhanced complex flavors and improves moisture retention in baked goods. So basically, browning is why baked goods look, smell, and taste sweet and good. Browning is either called a Maillard reaction or caramelization. A Maillard reaction is when sugar interacts with proteins and amino acids at high heat, and that happens more when you're cooking meat or baking bread. Yum! But that's not really what we're focusing on, caramelization, which is in baked goods. We're focusing on browning in baked goods, like cookies and cakes. Browning in baked goods is called caramelization, a reaction that occurs during sugar being heated above its melting point and breaking down into golden-colored caramel. The caramelized sugar becomes less sweet and more acidic and bitter the darker brown it gets, and the longer it's exposed to high heat. Caramelization leads to flavor, texture, and color development. The caramel color of caramel, the brown color of glazes and sauces, the crisp tops of meringues, and the cracking of cookie tops. The caramelization of sugars happens in multiple steps. First, sucrose is melted at high heat, 160 degrees Celsius, to break down into glucose and fructose. Then these individual sugars lose water and react with each other to form new aromatic compounds with complex flavors. Sugars brown and form intermediate products, the color precursors, such as methyl glycoxyl, glyceraldehyde, and furfural. Via enolization. These degradation products have fewer than 6 carbon atoms, and they polymerize to form high molecular weight compounds, which cause the color formation during the alkaline degradation reactions. In order to caramelize, sugar must be at a high enough temperature and at the right pH. This is because thermolysis, the breakdown of sugar molecules by heat, is dependent on temperature, pH, type of sugar, and catalysts present, like iron or copper pans. Heat also causes the dehydration of sugar, the breakage of their glycosidic bonds, introduction of double bonds into sugar rings, and formation of anhydrous rings. Caramelization is so important to the baking world. The caramelization of sugar contributes to the sweet flavors and tender brown surfaces of shortened cakes, the crisp crust and the golden brown color due to the caramelization of the guar on top of meringues, and the cracking on top of cookies due to sugar crystallizing and caramelizing on the surface of cookies. In addition, sugar enhances flavor development in meats and sautéed veggies when it's caramelized. It also adds color to barbecue sauces. Life's definitely better thanks to the caramelization of sugar because it allows us tasty and crispy baked goods, brown meat, and flavorful vegetables.